Today I'm going to do about binary number system. So in the previous video I told you to work out the binary system yourself and see, keep it. So now you can check with this one and see how you have done. Okay, so let's start. Binary number system consists of two digits only. I think several times I mentioned that 0 and 1, only two digits. And we, in the decimal number system also, we saw the number of digits in a number system is known as the base. So the number of digits in the binary number system is 2, 0 and 1 only. That's all. There is no other number, no other digits available in this. So therefore, the base of binary number system is 2. Similar to the decimal number, you have 10 digits, 0, 1, 2, 3, 4, 5, 6, 7, 8 and 9. That is including 0, 10 digits. Therefore, the base of decimal number is 10, whereas binary number system has only two digits, its base is 2. Okay, now its positional weight, now if you check the previous video, the decimal number weight goes as starting from the right side 1, then the left next is 10, you multiply by 10 because the base is 10 in the decimal number system, 10, 100, 1000, 10,000, it goes like that. But in the case of binary numbers, the base is 2. So we start with 1 and go left, right to left, same as the decimal number, but the multiples will be 2 in this case. In the decimal number, it will be 10 because the base is 10. Since binary number base is 2, the multiples will be 2. So if we're going to write the weight here, look at this. See, first you start with 1 anyway. So any number system, first thing you start is with number 1. In the decimal also we started with 1. In the binary also we started with 1. Okay, we can start with 1. That is not an issue because because the binary number system has two digits, 0 and 1. 1 is also there, so 1. Okay, and actually that is 2 to the power 0. To anything to the power 0 is 1. Right? But let's not worry too much about that. So now we'll go multiples of 2. So the next one is 2 into 1, which is 2. Again, 2 into 2, 4, into 2, 8, into 2, 16. If you go further, into 2, 32, into 2, 64, into 2, 128. It will go on like that. Okay, so these are the weight, how you write the weightage for binary number system. Okay, so let's first see how to represent the decimal number 14. Decimal number 14 means our usual counting number, the number which has 0 to 9. The number we used in the previous video. Okay, so that number I want to see how it looks like in binary system. So let's see. Right? Okay, so number 14, and remember binary number has only 0 and 1. So I can say 116 or 016. That's all. 18 or 08, 1404, 12 or 02, 11 or 01. Because only 0 and 1 I can use in the binary number system. So can I put 116? No, because the number you are trying to represent is 14. It shouldn't go to 16. So I can start off with 18, right? And this is 8 and 14. So 8 and 4 is 12 and 12. So 12 and 2, 14. We got the number. So that's why for 1 we put 0. We don't want any more numbers. Because if you put 1 here, it will become 15, right? So 18, 14, 12. This we can ignore. With 0 ones now, so we are not worried about that. So 18 plus 14, that is 12, plus 12, 14. So 1110 is how you write the decimal number 14 in binary number system. Okay. So how is it formed? 18 to 1. We are saying 1 of 8, so 1 of 8, 1 times 8 equals 8. Then we are saying 1 times 4, 4 we want 1, so 1 into 4, 4. 2 also we are saying we want 1s, so 1 into 2, that is 2. But 1 we are saying 0, so 0 into 1, that is 0. So when you add these numbers, 8 and 4, 12, plus 2, 14. So that again the same thing. So 1110 binary number is equal to 14 decimal number, right? So let's look at another example. 9. I want to represent decimal 9 in binary number system. How would I do? I will again start with 818 because I can't put 16 because we are trying to represent only 9. So 18 and 4 can we put? No, can't, because the moment you put 4, 14, it will be 8 plus 4, which is 12. But we are trying to represent only 9. So we don't need a 4. So 0, 4. We don't need a 2 either because 18 plus 2 will be 10. So we don't need a 0. So 0. 0 there. But we want 1. 8 and 1 will become 9. Okay, so let's see how it's formed again. 1 into 8, 0 into 4, 0, 0 into 2, 0, 1 into 1, 1. So when you add these two, 8 plus 1 is 9. So 9 decimal number is written as 1001 in binary. Okay, let's look at another example. 5. I want to represent the decimal 5 in binary number system. Okay, so 5, can I put 16? No. Can I put 8? No, because we are trying to represent 5. No, but we can put 4, 1, 4. And can I put another 2? No, because 4 plus 2 will be 6, but we want only 5. So put 0 there, but we need 1. So 1, 4 and 1, 1, which adds up to 5. Okay, so let's see. Again, 4 into 1, 4, 2 into 0, 0, 1 into 1, 1, add the 2, add these three numbers, you get 5. So decimal 5 will be represented as 101 in binary. Okay, right. So now let's do some conversion. We have the decimal number 7. I want to show in binary. Similar situation. I have 7. I want to show in binary. What do? This is the methodology I'm going to show you now. Okay, so you put a line like that and you put the weight. You put 1, then you put 2. That's a binary weight, right? Multiples of 2. 1, 2, 4, 8, 16, 32, like that. No. So 1, 2, the next one will be 4, right? Do we need to go to 8? No. Why? Because we are trying to represent the number 7. So 8 has no worth in that. I mean, we are not going to put 18 here. If we put 18, the number becomes more than 7. So since it's a number less than the next weight, we don't need to put that weight. So let's work with this. So to get 7, I will put 1, 4. Okay, I'll put just line there just to get this number onto this side. So this is the number we are trying to represent, right? So I can put 1, 4, right? Then I can reduce from 7. I have taken 4. So now subtract that to get that 3. So we have a balance of 3. So to represent 3, I can put 1, 2, right? So that means 2 also I have utilized. So less 2, the answer is 1. So I need 1 more. 1 I can put here, 1. Then I'll subtract that. Now we have 0. That is the end of it. Once you reach 0, there is nothing else to represent. The number has now become 0. We have represented all the numbers. So the decimal number 7 is represented as 111 in binary. Okay, and when you're writing this, what you do is you indicate the number like this, 7. This is the decimal number, and this is the binary number 111, 1111. And why are we putting this 2? That is because if you just put 111, all of us are used to reading this as 111. So to tell the user or whoever is looking at this, this is not a decimal number, but it is a binary number. Binary number base is 2. So you put the 2 and you put the 2 here, and when somebody looks at the number, they know, okay, this is not a decimal number, this is a binary number. So why are we not putting that for decimal number? You don't need to, because decimal number is the everyday number we are using. So when you see something without the base, then we have to assume, we will automatically assume that number is a decimal number, okay, like in this case. So this 7 is actually base 10, but we don't have to put 10. If you write any number without the base, then that number is a decimal number. If you write a number with the base, then that number is belonging to whatever that base is. So this is one way to write in binary the number 7, or you can put, instead of 2 here, the letter B to indicate binary. So 111B or 111 subscript 2, subscript 2, 1112 like this, or 111b. Either way, both are okay. You can represent this binary number 7 in this way or in this way, using the b or the 2. No issue. Okay. Let's do another conversion. Again, decimal number, you are trying to convert to binary number. Okay. So basically, we have the decimal number here. We want to see how this looks like in binary. So again, we put the weight. We put 1. Okay, the weightage starting off with 1. Then 2. Why? You have to multiply by base, which is 2. 2, 2, 2. So 1, 2, 4, 8, 16, 32. It goes on like that. So then we have the 2, right? Then we have 4. Then the next number will be 8, right? So in the previous case we didn't take, but here we have to take, because the number we are trying to represent is 8. So we will get the 8 also, and then we can say, okay, how do we write 8? We need 1. Okay, let's put this and get the 8 here. We'll say 1 8. Okay, so that means we have used up 8. So you put that 8 here, minus, answer is 0. Finish. So there is no more number left here to represent here. So then what you do is, in those locations you have to put, it's a must, zeros. So decimal number 8 will be shown in binary number as 1 0 0 0. Again, we write that the decimal number without the subscript, the binary number with the subscript. So 1 0 0 0, which is this 1 0 0 0. We are writing here with the subscript 2 to indicate, or you can write it as 1 0 0 0 b, either this way or this way. Okay, let's look at